Okie dokie, guys, let's take a walk down memory lane. We are about to soak our toes with SOHCAHTOA. Remember, SOHCAHTOA is an acronym we use to remember the sine of an angle, the cosine of an angle, or the tangent of an angle. Now, in trig, they like to use this guy. This guy's name is theta, T-H-E-T-A. Theta is a very commonly used variable for angle measurements. So, what they're going to do is they're going to give us some right triangle, and they're going to say, hey, we'd like you to remember what SOHCAHTOA is all about. So, they're going to ask me to find the sine of that angle. They're going to ask me to find the cosine of that angle. They're going to ask me to find the tangent of that angle. But before I can do all that, I need to know what all three sides represent. And right now I only have the two legs of my right triangle. So I go, okay, that's not a big deal. I'm going to use my buddy Pythagorean theorem that says a squared plus b squared equals c squared. And I could pick either leg to be a. So I'm going to say a squared plus b squared equals c squared. And in this case, I'm going to get 9 plus 16 equals c squared. But I got to add those together. I don't take the square root yet. That'd be crazy. I'd get the wrong answer. I have to combine these, and I say, oh, that's 25. That equals c squared. And then I'd root, and I would say c equals plus or minus 5, because it's a cheerleader equation. But we're talking about an actual triangle. So which one of those answers would we say makes no sense for this? We would say you can't use -5, so we're going to use just good old-fashioned regular 5. So I erased my plus or minus, and I go up here and I go, you are 5. Now, sine of theta means and I'm going to fill in the blanks up here, opposite over the hypotenuse. So the hypotenuse is always the one that's across from our right angle. Opposite is the one that I would go completely opposite of. So this guy over here is going to be opposite. This guy over here, ching, would be adjacent. And of course, the longest side and the side opposite our right angle is going to be our hypotenuse. And I'm hoping you're going, wow, cool, something I remember, I can do this. Opposite over hypotenuse. I am done. 4/5. Now, I got news for you. Please don't write 0.8. Now that we are all doing trig, decimal answers are only acceptable very, very rarely. And when they are, I will alert you to that. But we don't write any decimal answers. It's either fractions, whole numbers, or radicals. So sine of theta is 4/5. End of story. Cosine, well, I'd say, what is that all about? It's the adjacent over the hypotenuse. So I'd say adjacent over hypotenuse, so 3/5. Don't call it 0.6. We don't do that in trig. And then last but not least, tangent, I would say that is opposite over adjacent. So I'd say opposite the angle would be 4, adjacent would be 3. And I would have my guys. I would have my SOHCAHTOA. Now here's the kicker though. They're not going to be satisfied with just SOHCAHTOA anymore. No, no, no. They want us to know all 6 trig ratios. So I'm going to remove my work over here. I'm about to take all this away so I have a little bit of room. So here I go. I'm going to erase all this stuff, but I'm hoping you were like, oh, that wasn't that bad. I understand that. I remember good old-fashioned Pythagorean theorem stuff. I'm good. But here's what they're going to ask for now. They want me to tell them the cosecant of theta. They want me to tell them the secant of theta and the cotangent of theta. Now you'll notice that I lined them up the way I did because what is the cosecant? Well, the cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So what does that mean? Well, the cosecant would be 5/4. Take the reciprocal of your sine answer. The secant, what's the secant? It's the reciprocal of cosine. The reciprocal of cosine, so that would be 5/3. And then you guessed it, cotangent would be the reciprocal of tangent, so its answer would be 3/4. Now, the 6 trig functions. I just want to remind you that SOHCAHTOA has never changed. It never will. But I want you to understand that cosecant is called the reciprocal of sine. So if I did 1 over sine, I'd have the cosecant. Okay? That would be true. Totally true without a doubt. The secant is the reciprocal of cosine. So it's 1 over cosine. And then, of course, tangent here, my last dude, tangent of theta is 1. Oh, sorry, cotangent. I meant to write cotangent. I'll get rid of that. The cotangent of theta is 1 over tangent. And welcome to Flashcard City. From here on out, you're going to find so many formulas coming your way. It is so much easier if you don't fight it, embrace it, and just go with it, because these guys right here are never going to go away. We're just going to have them forever. Now, the thing is you said, well, look at your work. You didn't, for sine of theta, you didn't do 1 over that. You didn't do that. Well, what does it mean to take the reciprocal? It means 1 over it, but here's the shortcut mentally. If I multiplied the bottom of this fraction by 5 and the top of this fraction by 5, I'm not really changing it. I'm multiplying by 5/5. That's 1. What would I get then if I did that? What would I get if I multiplied top and bottom by 5? Well, in the top I'd get 5, and the bottom I'd get 4. So when I say find the reciprocal, the shortcut way of doing that is just to invert it or flip it over. Flip it over, right? So let us go through this little adventure together, because what your assignment is going to look like is they're just going to have you remember SOHCAHTOA, and then they're going to ask you for cosecant, secant, and cotangent. So I'm just going to sketch out another right triangle, but you know what? The only way they can make this kind of tricky on us is sometimes they'll write the triangle facing another direction, and they'll try to make it look a little trickier. But there's my right angle. And then they might do something like this and stick the theta up in the corner here. And what are they really just trying to mess with your mind on? Well, which side's the hypotenuse? Well, the hypotenuse is still going to be the longest side, and it's opposite the right angle. This guy now over here would be considered my opposite side, and then this guy over here would be the side that is adjacent to that angle. But we still can't do anything unless they give us some values to play with. So the very first one I did was extremely straightforward, no weird numbers. For this one, I'm going to use no weird numbers. So let's begin. I'm going to put a 13 here, and I'm going to put a 12 here. And you're going to say, well, they didn't give me the adjacent side this time. So remember, in Pythagorean theorem, a squared plus b squared equals c squared, the letter C always represents the hypotenuse. It's always the longest side. So I would have to say, well, one of these legs, I don't know what it is, but the other one, they told me it was 12. And then the hypotenuse is 13. So if I work on this one, I could say, well, a squared plus 144, 12 squared, equals 169. That's 13 squared. I could move this guy over then and subtract, and I get a squared is equal to 25. And I go, hey, I was just here, but it was a little bit different how I got here, because this time I'm looking for the missing leg. And algebraically, I would say a equals plus or minus 5. But you know what? We don't need the plus or minus. We're just going to deal with positive 5. So the missing piece here, this adjacent piece, is 5. Hey, guess what? They still want me to find the sine of angle theta. They still want me to find the cosine of angle theta. They still want me to find the tangent of theta. But they're also going to ask for the reciprocals. So to make your work easier, always line them up with their reciprocals. See, sine of theta has a reciprocal. Its name is cosecant theta, and we abbreviate it CSC. So I go, wait a minute, I can find the sine of theta pretty easy. The sine of theta would be opposite over hypotenuse, which means I automatically know this answer is 13/12. Let's do it again for cosine. If I want to know what the cosine of that angle is, I would say adjacent over hypotenuse. So what do I immediately know? I know the secant of theta is 13/5. And then last but not least, my buddy tangent, I would do SOHCAHTOA, so it'd be opposite over adjacent, which would mean my buddy the cotangent would equal 5/12. Boom, there you go. They're going to ask you for 6 trig functions. Really, that's what they're going to do. Oh, my voice cracked. So let's look at another one. And what do they do? Remember, sometimes they try to mess with your mind by doing something like this, and they're going to do it in the problems we're doing. Where, hey, what about this? And what if I stick theta over here? You know what? Some people hate it when they do that. Me, I don't like it when they do that. But you can always redraw the triangle if you want. If you want, you could rotate it. If it makes your brain happy, I don't care. Rotate it. If you want to, you could do this. Oops, I didn't make that long enough. And then you could say, wait a minute, which one did they give me? That guy would have been the theta. And then opposite the theta is the 4. And then did they give me the hypotenuse? No, so the other one must be 6. If it makes your brain happy, you can redraw the triangle. A lot of people do that because it makes their brain happy. This time, if I do my a squared plus my b squared equals c squared, I am actually looking for the hypotenuse. So I could say, okay, one of these legs is going to be my a value. So I'm going to just go over here and say 4 squared plus 6 squared equals c squared. And then I could say that's 16 plus 36 equals c squared. And then what is that? I think that's 52 equals c squared. And then I do root, right? And I'm going to stop doing that plus or minus thing. I'm not going to write plus or minus rad 52, but I wouldn't write plus or minus rad 52 anyway, because I know that 52 can be simplified. It's 4 times 13. So what comes out? Square root of 4 would be 2. Here, I'm going to write this a little bit better. I'll get rid of that for a second. This would be 2 rad 13. That's what C is equal to. See, you have to write your answers in simplest form. And what is the one thing I already said? When we do trig, we never use decimals. So do not give me a decimal there. That would be the guy I have to use now. Okay, well, let's do it. And you'll see, I'm not even using this triangle that they gave me. I'm using the one that looks easier to understand. I rewrote it. So I'm going to do sine of theta. Now, you know what? I'm going to do them one at a time this time. So I'm going to do the sine of theta. So I would say opposite over hypotenuse. And I would say that's 4 over 2 rad 13. Now hold on a second. These are both outside numbers, 4 and 2. I could reduce that. Outside numbers reduce outside numbers in radicals. It's true. It's totally true. It's not a lie. So I'd have 2 over rad 13. But then you get your test back and it's marked wrong because why? You cannot leave rads in the bottom. But I want to give you guys a total heads up here. Please try to wrap your mind around this. I found the sine. It's not completely done yet. But I'm going to take a little pause here and say, you know what? I know what the cosecant is. If I took the reciprocal right now, I'd have rad 13 over 2. Here, I'm going to put a line here so you can see them. Okay? I would have rad 13 over 2. I don't have to get the radical out of the bottom. It's done. But over here, I'm going to come back and say, you know what? Let me finish this off. And then what would my sine answer be? My sine answer should be 2 rad 13 over 13. That is where trig gets fun. You have to be very, very polite. So that would be the sine answer, but guess what? The cosecant's already done. I got it because I took a second to pause and write the answer out. Now guess what? Same thing's going to happen here with cosine. Let's play with the cosine. I'm going to give myself a little more room here. Cosine of theta is going to be equal to adjacent over hypotenuse. So I'm going to say adjacent over hypotenuse. And then I say, wait a minute, same thing. This guy's outside, this guy's outside. I could reduce, and then I have 3 over rad 13. Now, I know I got to get the rad 13 out of the bottom. I do. But I say to myself, hey, let's just put the brakes on for a second. I can tell you the secant would be the reciprocal, and that would be rad 13 over 3. I don't have to clean it up now. That's as pretty as it can get. Beautiful. There's no decimal. My answers can never be decimals in trig here. But I'm going to finish this. I'm going to go back and say, can't leave the rad in the bottom. I'm going to do this. I'm going to end up with 3 rad 13 over 3. Now that's the answer for cosine. Oh man, tangent. Well, tangent's actually nice on this one. Let's do the tangent of theta. Tangent of theta would be opposite over adjacent. So I go, oh, that's 4/6. Please reduce. Please reduce. Call it 2/3. Thank you. That's what I want for tangent. And then what would cotangent be? Well, cotangent would be 3/2. I mean 3/2. I like to call it 3/2. I don't know why. So guess what? Sometimes you run into radicals. That is basically the whole gist of this lesson. To remind you of soaking your toes and to introduce to you cosecant, secant, and cotangent in case you've never heard of them. But the thing is, all numbers have a reciprocal. And what is a sine, a cosine, or a tangent? It's just a ratio. It's a numerical value. You can find its reciprocal. Guess what? They have names. What are the reciprocals' names? Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent's the reciprocal of tangent. They have specific names. Now, the thing is, the hardest part about doing this is when you run into radicals. So let's just do one more example where we, got to do this. And this time, I just want to go straight forward with my triangle. I know when you see the practice problems, you're going to go, dang, they got a couple of those upside down kind of guys. Well, let's just go right side up. And then they're going to stick a theta in there somewhere. What the heck? And what if they gave me something, like, oh, how about 4 and then 7. Wait, you know what? I'm sorry. Let me get rid of that. Let's put the 7 over here. Whoops. Because my last example, we had to find the hypotenuse. I don't want to do that twice. So let's do it this way. Hey, I don't know what this guy is right here. I don't know. But I do know Pythagorean theorem is going to say one of these legs I don't know, plus the other one I do know, equals this dude, because, oh God, that's a horrible looking 7. Anyway, I'm about to square it, so it won't matter. So a squared plus 16 equals 49. Vamos a subtraer, o sea, resta, take away. A squared is igual a, okay, so what is that? That looks like it's 33, right? Looks like 33 to me. Yeah, okay. Let's take the root. And then I go, oh, so this question mark here, this missing piece, that was actually rad 33 in disguise. But the nice thing about 33, you can't pull anything out of it. It's not simplifiable, so you just leave it there. But please, please, please do not turn it into a decimal. So let's try this. Let's do the sine of theta. Let's do the cosine of theta. Let's do the tangent of theta. But follow my hint. Let's do one at a time. Let's see, because sometimes you save yourself a little work. What would the sine be? It would be, well, over here, this guy's the opposite. This guy's the hypotenuse. So I would say sine, opposite over hypotenuse. Hey, I can take the reciprocal of that real easy, and I'm going to call that answer the cosecant. And it's going to be 7/4. Hey, let's do the cosine. If I wanted to do the cosine, well, I'm going to do the adjacent over the hypotenuse. So I go adjacent over the hypotenuse. Totally cool. So let's find the secant. And I say, what's the secant? It's 7 over rad 33. And then I go, wait a minute, I'm going to get marked wrong on the test with this one. I better multiply top and bottom by rad 33. And then I will get 7 on the outside. It doesn't go in. 7 rad 33 over 33. Now, please do not reduce this. Outside numbers can reduce each other if they have a common factor, but outsides and insides do not hang out with each other. Okay? Outsides and insides never mess with each other. So that answer is solid. It's done. Finished. Let's talk about the tangent. If I wanted to do the tangent, I would say opposite over adjacent. And then, wait a minute, I'm going to put the brakes on for a second. I know I have to get the rad out of the bottom there, but I'm going to jump right ahead and write down my answer for cotangent. I'm trying to show you how to take shortcuts. And just flip that baby over. Let's reciprocate it. Boom, cotangent, you are done. But I come back to tangent town, and I say, I need to do a little bit of cleanup here in tangent town. Things are a little messy. That's what they call, I guess, that soccer player. His little kid is a little messy. Ha! Get it? Messy? Soccer player? Anyway, horrible joke. I'm sorry. All right. I think if you guys look, there's 1, 2, 3, 4, 5, 6 answers. You're going to see this on your next unit test, so remember, I'm going to scroll up now. Check this out. Whoop. Okay. Remember, no decimal answers. Simplest radical form only. Number 10, you could do number 10, but you know what? It's just, it gets really ugly, and I need you to understand how to do this. I don't need to torture you. So, 5, 6, 7, 8, 9. Those are the ones I want you to do. And it says, in exercise 5 through 9, evaluate the 6 trig functions of the angle theta. All right? Now, theta, some people draw it like I do, where you go like a circle with a curly Q. And some people just draw like an oval with a line. That to me looks like Ike from South Park, kinda. But that is a very common variable in trig. You're going to get used to it because it's all over the book. It really is. Now, these 5 practice problems do have answers. So take a picture of this. Then, here we go. I'm going to scroll down to the answer key. These problems, though, just so you know, are from the Big Ideas book. I just wanted to pick out some problems. So if you can't read the assignment, well, you know, some people, oh, I can't make out what it says on the screen. Well, it's on page 466 in the Algebra 2 book. Not the trig book, the Algebra 2 book. Page 466, 5 through 9 all. So this is, the assignment is evaluating trig functions, aka the SOHCAHTOA review, plus something new, and that's the reciprocal functions 2. My rhymes are fresh, as if you didn't know. Anyway, I'll stop. That was really bad. Here are my answers. Exact values, just to remind you, means. Never use decimals. Your answers could be fractions, they could be whole numbers, or radicals. And if you look at the answers right there, you will see none of them are decimals. Okay, so guys, do some practice, soaking your toes. All right, catch you later.